In this exercise, we're going to demonstrate more use of inheritance by working with geometry, in particular quadrilaterals, and objects that are based on quadrilaterals. So we'll start out by creating a quadrilateral class. We'll have 4 fields that are protected. 4 sides represent the quadrilateral. So those are our fields. Next, we'll build a constructor. So we need 4 parameters to represent each side, S4. Then we simply assign each parameter to a field as appropriate. After the constructor, all we need is a function to display information about our object. So we're going to write a little display method. And then display each side with a space. And there's our class definition. So now we're ready to create a derived class from this base class quadrilateral. The first one we'll do is a trapezoid. A trapezoid is a type of quadrilateral where 2 sides are parallel. We are not going to try to enforce that constraint. We're simply going to demonstrate how to inherit the characteristics of a trapezoid. And all the inheritance, of course, is done right here. And when we say public quadrilateral. So all we need is a constructor that works pretty much just like the base class constructor does. In fact, we will call the base class constructor with the 4 parameters. So that's our complete class definition. Let's create one more class, square. Of course, a square is a quadrilateral where all 4 sides are equal. So for this particular constructor, we simply call the base class constructor with 1 side. That's all we need because the sides have to be equal. Remember, we are defining these based on the sides of the object. So here are 2 derived classes, trapezoid and square. We see how we inherit using the public quadrilateral phrasing. Then notice how we call the constructor by naming our derived class constructor and then in the definition. And then as soon as we finish our parameter list for the derived class constructor, we put a colon and the base class constructor is called with the parameters listed above. And then finally, because we don't need to make any other changes, we have a empty body. Let's go ahead and compile this. Let's build it just to make sure we don't have any errors. And we don't, so that's good. So let's create a couple of objects. We'll just put some links in. Doesn't really matter too much. And then display each object. T1 display, S1 display, build and run the project next. And notice that display automatically calls the quadrilateral, and that's part of what happens with the base class and a derived class. I left it in here on purpose because in our next chapter on polymorphism, I'm going to demonstrate how to modify these functions so they know how to work with the correct type of object. So I understand that what I could have done was go back into these 2 definitions, trapezoid and square, and redefine display to show trapezoid and square. I'm saving how to do that for the next chapter on polymorphism, where we'll learn how to work with these objects at runtime versus at compile time. So that wraps up this chapter on inheritance, and we're now ready to move on to the next chapter where we discuss polymorphism.